Hello and welcome to math. Today we're going to talk about functions. All right, so functions. Functions. A function is a relationship with one or more ordered pairs where each input or x value has a single output or y value. Okay, each input or x value is only allowed to correspond to one output or y value. Okay, so this is a function machine down here. And going into our machine is our input or our x values, or we learned last couple times domain. Okay, so we want one thing going in and we want one thing going out, and that is our y values or our output or our range. Okay, so we have to see if something is a function or not. So we want all of our x values to only have one output. If x value goes to two outputs, that doesn't work. That's not a machine that is broken. So it was not a function. All right, let's go on and see how we can do this in ordered pairs. Okay, so in ordered pairs, we want to look at the x values. The relation will not be a function if an x value goes to more than one different y value. So let's look at this example here. Let's look at my x values, which are my first numbers. I have -3, -1, 0, -1. -2. This is not a function. Why? Well, it's not a function because my x value of -1 repeats. My x value of -1, it goes to two different values. It goes to 2, -1 is paired with 2, and it's paired with 6. That is not a working function machine. -1 can only have one output. It can't have two, so it is not a function. Let's see this next one. Let's see, -2, -1, 0, 1. This is a function. And the reason why it's a function is because all of my x values are different. I have no x values that repeat. They're all different. Every x value goes to one y value. Whereas this one, this x value of -1 went to two different y's. That doesn't work. This one, every x goes to its own y. So it's good. It works. It is a function. So in short, if your x values repeat, not a function. If all your x values are different, it is a function. All right, so let's look at our practice. Let's see, I have 1, -1, 0, 2. All of my x values are different. So yes, that is a function. Let's look at my next one. 1, -1, 1, 2. Let's see, whoa, I have 1. 1 repeats. 1 repeats. 1 can't go to 7 and 2 at the same time. Not a function. All right, let's see the next one. 2, 3, -2. That is a function. All of my x values are different. They do not repeat, so it is a function. All right, so that's how we do it in ordered pairs. We just look at our x values. If they're all different, it's a function. If they repeat, it is not a function. Like this example here, -1 repeated, not a function, okay? And a table, let's do a table. Table, we review the columns, all right? We look at the columns. We have an x column and we have a y column, right? The relation will not be a function if any x corresponds to more than one y, or any input corresponds to any different output. Okay, so let's look at this one. I have 0, I have 1, I have 2, I have 3, I have 4. They're all different. So this is a function. Woohoo! Function, it's working. All right, and the reason why it's a function, all of my x's are different. All of my x's go to its own y. It doesn't go to two y's, it goes to one y, so it works. It's all good. All right, so let's look at this example. My x values, I have -3, 2, -3. Uh-oh, I see a repeater, -3. Let's see what it goes to. -3 goes to 1 and -1. That can't work. It can't be at two spots at the same time. -3 I can't put in my machine and get 1 and -1. I can only make one thing. So this is not a function. Not a function. Because at least one of the inputs, or my x values, has more than one output, or my y values. -3 can't go to 1 and -1. Doesn't work. Okay? So let's look at practice A here. -1, 0, 1. All my x's are different. Function, yeah. Let's see B, 3, 0, 3. Oh no, 3 and 3 repeat. When they repeat, not a function. All right, let's look at this one over here. Ordered pairs again. Let's see, 3, 4, 2, all different. Function. Let's look at this one on the right. 1, 0, 1. 1 repeats. Oh no. If x value repeats, not a function. Cannot be a function. 1 can't be paired with 8 and -3 at the same time. Not a function. Doesn't work. All right, so that's how we do it on tables and on ordered pairs. We look at our x values. If all of our x values are different, it's easy. It's a function. If they repeat, not a function, because 1 can't be paired with more than one thing. It can only be paired with one thing. 1 can't be paired with 8, and it can't be paired with -3. It can only be one or the other. Okay, so that is not a function. That is not a working machine. All right, let's go on to mapping. Okay, so this is mapping here, right? So mapping are these little bubbles, all right? And our x is always on our left, and our y is always on our right, right? It will not be a function if an x or an input maps to more than one different output, or y. All right, so what I mean by mapping, all right? So x, my x value of 4 here, it only has one arrow. This arrow is pointing to 3. It only has one match. We're good. 6, it only has one match. It's matching with 3. That's cool. 8 only has one match. It's matching with 2. Cool, that works. 10 only matched with 2. That works. 12 only matched with 1. That works. Awesome. So this is a function. This is a function because none of the input or x values have more than one output or y values. Every x has one match. All right? This one over here, though, this one on the right, is not a function. Not a function. And the reason why it's not a function is if you look at all those arrows over there, remember we want the x values to only have one arrow. We only want it to have one match. So -8 only has one match. That's cool. -1 only has one match. That's cool. 0 only has one match. Cool. But this 15 has got 2 arrows. It's matched with 7 and it's matched with 9. That does not work. So our x values go to different y values. 15 can't be at 7's house and 9's house at the same time. It's not possible, right? So it's not working. It's not a function, right? So when you're looking at mapping, you just want one arrow coming from each of the x's, okay? All right, let's look at the practice down here. Let's see, -4 has one arrow, sweet. -2, one arrow, sweet. -1, one arrow, sweet. 4, one arrow, sweet. They all have one match. We're good. Yes. The second one over here, 3 has got 2 arrows. 3 can't be with 16 and 4 at the same time. No, 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 no. Can't happen. So it's not a function. Okay? So with mapping, you're looking to see where it maps to, where it goes to. 3 can't be at 2 places at the same time. It can't be at 4's house and 16's house at the same time. It's not possible. Right? So we want all of our x's to only have one match. All right, let's go on to graphing. Okay, when graphing, we want to do this thing called the vertical line test. And remember, a vertical line is straight up and down. Okay? A relation will not be a function if the vertical line passes through more than one point. Okay, so what do I mean by vertical line? All right, so vertical line. If I draw a vertical line, a straight up and down line, and I have this graphed curve here, that graphed curve only hits that line at one point. No matter where I draw my line, that graphed line will only hit it at one point. Okay, so that is a function. It only touches once, no matter where I draw my line. Okay, so let's look at this one on the right. This one on the right is not a function because if I draw a straight line right here, straight vertical line, I have 2 points on my line. 2 points on my line means it's not a function. And the reason for that is you can see that this thing crosses the x-axis, right? So that means everything on this line has the same x value. So if everything on the same line has the same x value, this point and this point have the same x value. So therefore our x's repeat, and therefore it's not a function. Okay? All right, let's do this one over here, this bottom one. All right, let's draw a vertical line, straight up and down. Boop, it only hits once. If I draw a line here, boop, it only hits once. If I draw a line here, boop, it only hits once. So no matter where I draw it, it only hits once, right? So we're good. It's a function. This one on the right, if I draw a vertical line here, hits the graphed line twice. 1, 2. That means everything on this x of -1 here repeats. So cannot happen. My x values repeats. Doesn't work. Not a function. Okay? So basically, when you're looking to see if something's a function or not, you're looking at your x values. If all your x values are different, it's a function. It works. All your x's have one output. If your x's repeat, it's not a function, okay? Because x's can't be at more than one spot at the same time. Like on this graph here, we can't have things be at the same place. It doesn't work, right? Okay, so that is function or not a function, right? So if something's not a function, it's still called a relation. A relation is anything. It could be Any graph or table or ordered pairs you look at, or any mapping you look at, all those are called relations. Functions are a special set of relations, all right? So that is function or relation, or function, not a function, and that is how we do that. If you ever have any questions, please ask a teacher, and I'll see you next time. Bye!